Good afternoon and welcome to the webinar integrating tool management systems and the machine simulation to increase your productivity. It's a webinar presented by ZOLLER and HEXAGON. My name is Silver Proisi and I will be the moderator for today's webinar. In this webinar, we will learn how to manage and organize tool in TMS, how to export the tool information into NCSimul, easily transfer the tool list into the simulation, and use the tools for your verification and optimization purpose. All of that to create a more efficient NC program. You will see how easy it is to transfer a set of tools for simulation from TMS, basically. A little bit about the company. So ZOLLER is a company established in 1945 and provides solutions for tool presetters, measuring machine, and tool management software. HEXAGON, the builder of NCSimul, has been created in 1819. It was named Kern & Co. and is a provider for smart factory, including metrology, hardware and software, production and engineering software. And at HEXAGON, our focus today will be digital twin machine simulation and optimization for CNC machining. The partnership provides a connection for user between the tool database TMS across programming processes, including, of course, NCSimul. You will be able to transfer a full tool list needed for a job through a setup sheet in TMS. You can also transfer a single tool. So let's say you are working with a job in NCSimul and you did a specific tool from TMS. You will be able to transfer that single tool. You will use realistic tools, 3D in NCSimul verification, and those tools will be generated by TMS. All of that are for the benefits to ensure a valid tool data when you do simulation. You have no tool data redundancy because everything is managed from the tool management system. And you can accelerate NCSimul job preparation. So, sorry about that. So the ZOLLER TMS interface can transfer ZOLLER scan tool in the TMS software and will carry on the NCSimul simulation. The interface is, of course, evolving with new customer demands, and we are expanding the tool that has been exchanged between TMS and NCSimul with new tools and new data, I would say, every month or every year. As you can see on the picture on the bottom, you have the tool presetter ZOLLER that sends information to TMS for the tool shape. And also you can use external tool libraries such as Machining Cloud, Tools United, and others. And everything is transferred from TMS to the simulation NCSimul, the magazine of the tool. If you do use a CAM system, of course, this will be integrating as well your CAM. So instead of sending directly the tool from TMS to NCSimul, you can also send it to a CAM system and then send it to the simulation. So either way, you can send the tool directly to the simulation or go through a CAM system that you have to program your CNC programs. About the presenter of today, Cedric Hazenfratz, he is national sales at ZOLLER. And then Christopher Parker, who is a product specialist for NCSimul. The webinar will be 45 minutes of content and is going to be followed by a question and answer session with our presenters. You can submit your questions at any time during the presentation using the question panel on the webinar dashboard, and we will address the question after the presentation. Without further ado, I will now let Cedric Hazenfratz presenting TMS software. Cedric?
Hi everyone, this is Cedric. As Silver mentioned, I do the national sales and partnership for ZOLLER on the TMS side of things, trying to make sure all the tools that we are presetting within ZOLLER can be organized, and now today, as an example, being transferred to NC-Simul, the cheat code simulation. So going quick here in the partnership real quick on what the main goal is on an application side of things is really to have a complete standardized database with digital twins. Most important now, even for cheat code simulation, is that those tools are 100% correct and can be verified within the cheat code simulator of NC-Simul from ZOLLER. So those tools shouldn't change, should look the exact same, and it's a nice way on the ZOLLER side of things to see the tool in action and making sure it does the job correct the first time. Today, we'll cover the actual benefits of an external library. Why don't you use your CAM or NC-Sim tools library, and why it's so important? Because in today's world, we are all familiar that there's many companies using maybe more than one CAM system or using a CAM system and verification. And we'll be showing you how you can push out those tools with one single button to all of your CAM or verification systems. And of course, we would like to give you the latest and greatest advancements of managing the ZOLLER tool library with our new 1.18 release, and obviously also the updates on our connections to NC-Simul cheat code verification. So that's kind of the goal of today, so that way we can give you an input for our existing customers and also a little bit of a review for our prospects that want to see more about either ZOLLER or NC-Simul, or obviously both of the integration. First one is the example with the tool management solutions. We're going to use the same tools and show you live in just a minute how that tool can be transferred. I'll get more in that specific window right here on how this tool is being assembled within ZOLLER, how you can assemble it, either bringing it by the cloud or recreate it from scratch within the ZOLLER database. And the next one is to transfer that. So the tools are organized. We're creating a setup sheet within ZOLLER. I will be showing that live too, just to really confirm the ease of use, and then transfer those setup sheets with tools into NC-Simul. That will be all handled live, and from there on, once it's transferred, our other presenter, Christopher Parker, will take over. So here is basically the example of that digital twin that we really want to show you live with the ZOLLER TMS tool being transferred to the NC-Simul cheat code verification solution. General interface specifications is drilling, milling, and turning tools can be used. And we are going to transfer basically the STL files for holographics that are used. As you can see, that contour right there in the screenshot just beneath. I think we're going to use 4 tools today, and we'll again present that live right there. So let's head over to the live demo. I'm going to close that window real quick. If Chris, you can give me the screen for the tool management solution. No, I think you have it loaded, Chris, on your screen, so I can just use yours.
Can you send me back to the presenter then, please?
Sure. All right, so we'll get that interface loaded now. We're just going to use one screen today to make it easy for everyone without switching the screens back and forth. All right, we'll load that up now live and get you a quick, nice input of it. So here we load our ZOLLER TMS database right now. And what we did beforehand, we created an actual group library of NC-Simul tools and ZOLLER tools that we will be transferring. And again, during that process, I'll also create that setup sheet so you can nice and see the benefit on how easy it is to create a setup sheet that you can use for your verification. And Chris, if you have a password, let me know. And if you don't, let me know.
I do not. You should be able just to go right in.
Perfect. Before we get started, is there any other specific questions before we go into live demos? I'm sure there will be more coming up as we go along, but while ZOLLER is loading, let us quickly know if there's any other question. Use the icon on the right side for questions with the question mark on it, and let us know. So I'll let Sylvain read. There's 2 questions that just came in. Let's answer those while we are loading the actual live demos. Sylvain, if you want to read the question.
Yes. So I have actually one question. We will be able to get a copy of the PowerPoint? So the answer to that question is yes. And I think you guys just have to refresh the connection to the computer because it's not active. So Christopher, you just have to reconnect. And then the second question is, will you be demonstrating how the ZOLLER presetter can capture a tool profile? So the ZOLLER presetter, I don't think so, but you can answer maybe, Cedric.
Yes, that is possible. So most likely with the tool presetter and the ZOLLER, tools are automatically captured. So if you were to take a measurement within the presetter, you don't have even to push a button. It's automatically synchronized to all the measurements you do on the presetter, and you do have TMS. This will be actually immediately being captured in the ZOLLER TMS, and you will see those measurements. And I will show that in my live demo on how this will look within the ZOLLER database.
And there is a follow-up question, and I think we're going to get back, but let me ask this question. How it will be distinguishing between tool and holder?
So basically for the verification part of it, I mean, from ZOLLER, the presetter to the tool management, it can be the whole tool, or if you just need to have a certain cutting edge that you want to transfer, that's really up to you and what type of measurement you want on the presetter. And from there, from ZOLLER to NC-SIML, obviously it's important that we bring in the full tool because we're going to go into a live, machining environment that's complete reality as those machines are built like on the real shop floor. So yeah, let's head into the demo. I can give you a bit more input about the whole setup here within ZOLLER TMS. So right here, I would like to give you a bit more inputs on our database. So we have basically here a complete menu where we have different modules of ZOLLER TMS. Today we are going to focus mostly on the tools because we don't necessarily transfer the single components, which we most likely will transfer and is most important, the full complete tool assembly. So what you can see here, I did have this history data right here, so we can see on who made a change, what time, and which user wanted to make a change. So that's important for me now during the live demo, as there will be questions later on. I can track back and definitely see on what I changed and what tool and what I showed to you. So within the tool, you have here the first tool. Can also click here quick on the ID number, which now shows me the library of NC-SIML with screenshots on what there is available for me. So you see our tools that we will be using today and being transferred to ZOLLER to NC-SIML. So I'm going to load that first tool here and confirm that one. Here is my information about the tool, a few more details on them. I have that I button, so this goes back to the sim components. So I'm going to open that. It's going to show me now the milling inserts of that specific tool. When I head back, I want to look at the second component on how this tool is assembled. Let me get out that one. Here is the cutter now. I'm going to take a look at the cutter, so I can just hit that I button right here. And now I get more information. Again, on the right side, I see exactly who was creating that specific component. Within the component, we have the graphics attached to. So for that drawing, we have following graphics that we need for it. So there's DXF, there's a step file, and also a CAD, and one more that's more specific to the cam. Then we also have the usage list of the specific component. So that's very important, I would say, especially on the cutting side of things. It's going to really give you more information about where has it been used, the quick description and which position. And you can go in more details and see the actual utilization record of it. So here you get a lot more data of that specific cutting area right there. So that's kind of a big also on the usage side of things. You can see here there is the machining side and clamping diameter that we need to assemble that tool. So when I go back here, looking at those tools, you see the complete assembly. I go to my parts list. So right here, I have a 2D graphic. So right here, I see all the parameters that I need for this specific tool. And even more so here, the 3D, which we can create with just in a few seconds. It's going to create a 3D view for you that you can double check on the tool and visualize a little bit more on what you actually assembled. Whatever change you make here, it will recreate that within a couple seconds. So let's just imagine you were missing some of your components. It's going to take you some time. It could take maybe up to 20, 30 minutes till you actually could recreate a graphics and drawing for that specific new tool assembly. So within ZOLLER, as you could see, we created that 3D graphic within 3 seconds and gave you a nice overview. Looking at the next tool, we're going to go back quick to manage tool here. We're going to show you quick all the tools that we will be transferring. So I go back to my tool ID, go to the specific drill right here, loads it up. Here's my 2 DXF graphics, have the same situation. I get my actual overview on the components. And if I were to need to add a pull stop or anything, I could simply here hit the plus sign. And now it's going to give me the whole library if I need to and can look for pull stop. But I do have a filter right here that I can quickly show you on how I can get that pull stop out. So all I have to right here on the top right to filter it is pull, and it brings me that specific component. I confirm this with F1, and now it's going to attach that specific component right to it. So that's how easy you can just simply attach certain components if you want to. In this case, I don't need it for the verification side of things. I'm going to just let that go. Something is restarting, Chris. I apologize for the technical challenge right here. Chris, I can't hear you.
I'm trying to restart the connection to the computer that we're working off of.
We'll take the time to get more questions in. I see there is plenty of questions coming in. I'll let Sylvain read those questions to us while Christoph is restarting. I think this is a perfect time because after this specific demonstration of getting the tools together, we'll just finish with the setup sheet and then give you the live demo on transferring the actual setup sheet over to NC-Simul. So Sylvain, go ahead and read a few more questions that we have.
Well, for now, we have addressed every question that was, I would say, common. So I don't have any more questions that can interest everybody.
Okay. Let's go to that question. For how long has been NC-Simul and ZOLLER have the interface for? I would say it's about 2-3 years now, or what's the number there that we had started the interface? I'm going to get my screen up in just a minute while you're loading yours, Chris, in just a minute, and get my TMS up to do the setup sheet. That way we don't lose time and keep our attendees engaged with the actual setup sheet. And hopefully by that time we can get back to you with the live demo of the NC Symbol with the integration. Does that sound good?
Yeah, that's all good. I'll start TMS again for you.
I mean, it can get started if you need more time.
All right, go ahead.
Okay, so the tools that you have seen just before, I'm going to now take those and put them in a setup sheet. In case there was a question about the graphics on how and where the graphics reside for this specific tool, they are on the desktop environment, not to make the software too heavy, but each time we do bring in the tools for the assembly, we will have those graphics within ZOLLER TMS. So like I showed you before on the face mill here, it is directly within ZOLLER that it's being shown. So I'm going to go to tool number 2 just to give you a better view here. We'll get the tool number 2 first and pick up on where we left off. I'll pick that tool right now, and again, all those graphics are now also attached within that. I can also always add more if I need to for the CAD CAM model like we saw with the face mill. So everything looks good, the parts list, so the tools are assembled. I have my library basically almost created. I just now need to get ready and get a setup sheet up and going. So I go back here to my menu now, and I will create my setup sheet. So right there is my setup sheet calling NC Symbol ZOLLER. And how you can create that, I'm just going to create a quick new one to demonstrate it. So what I would do is hit here F10, create a new setup sheet. So I will give it a new name and call it the ZOLLER NC Simul Demo Setup and Designation. I'm going to quick and call it with a similar name, NC Symbol Live Transfer. And then the machine we're going to pick today is a UMC 750. So I can pick the machine right from here where it's going to go on to. Department, I can add that if I want to. So everything here is basically up to you. Whatever information you would like to add, you can. Of course, the material, the drawings, the view of the unmachined part or the finished part view, that's really up to you. And of course, you can also add the color material if it's necessary to add that onto. Then we go to tool data. So within the tool data, that's where we're going to bring in those tools that I created. So I can go here in my selection. I have all my NC Symbol tools. So what I can do, hit Shift. I'm going to take the first 4 tools that I showed you before right here, T1 to T4. I think have been a good example to use. So now I have selected them. I hit OK. And now they're all added onto. So now, very important to see here is this is the same exact screen as you have with your solder presetter if you have one. So all the information that you took when taking measurements are immediately captured within TMS2. Not even having to push in a button to transfer it, it's all synchronized, single source database. So this now is done. I can save that setup sheet. Looks good. I can select a group if I want to. I'm going to leave it with the webinar right now if I need to. And once that's done, I could, if I want to, add NC program management, the programs itself. I can also add test devices if I need to, and fixtures, which I don't have any for this example. So we'll just go and really show you the tools itself. So last but not least, let's see if you can get a quick view of that setup sheet. So I'm going to give you a quick overview that can be used with barcodes or not barcodes. So right from here, it creates now a quick overview of a setup sheet that can save here within a specific folder. All right. So that being said now, again, I have my tools created. I have my setup sheet that's ready with all the tools that I need. And again, at any time, I could look in the iBot and see the assemble tool to get more information about the specific tool. So that, without further ado, I'm going to give it over to Chris Parker to show the actual interface and give you a bit more input quick on what our next steps are.
Okay, thank you. Do you mind just exiting out of ZOLLER before I take over? Nope, not that one. Okay. So here we go. Sorry about that, but I'm starting up NC-Simul now so that I can show you exactly where we can pull what Cedric has just saved. And then the idea is that you have this project that you've created either inside a CAM system that you've exported or that you created in Scratch from NC-Simul anyway, and it's sitting there waiting for tools to be loaded. So that's all the error messages that you're seeing inside NC-Simul right now. It's saying that tools don't exist, so it doesn't know how to handle it. And then all you have to do at this point is head into our tool magazine. And opening this is going to give you an opportunity to create the configuration on the spindle. You have the option to load a single tool from anywhere or an entire tool list like Cedric just built. And with our connection, this is looking directly at ZOLLER's database. And I can drop down and look at anything that has been created. So I think we made the webinar tools for this one and hit OK. And it's going to look right inside ZOLLER and start bringing those tools in immediately. And there's the ones that you should have seen. So 1, 2, 3, 4, I think were the first 4 we made. And then you can manipulate them however you want. Inside here, you can see that it made the cutting portion, the non-cutting portion, or sorry, the cutting portion at the bottom, the non-cutting, and the holder. And then I can set additional things if I'd like from here. So for each tool, if I wanted it to cut in a different color inside NC-Simul, I can start either identifying it manually or just saying have a default color for each tool, just so you can see what each one is doing, and then just hit apply to put it onto the spindle. So as soon as it does that, we should have this thing here that's saying tools from tool database. And then once we're inside the program, you should see those same tools loaded right into the spindle in NC-Simul. And all you have to do from there is hit play and you start the actual simulation. So that's the idea of everything that you have to do once things are set up between ZOLLER and NC-Simul. And yeah, so I can show you a more specific example with NC-Simul once we're inside here, but that is just the basic way to get tools in and out of ZOLLER and NC-Simul. So for now, I'm just going to close this and head back and just go over a couple more things before we jump into the other official demo. Okay. So what we're going to go over on an NC-Simul side, we just saw how to get the tools in from TMS, and we saw it came with the complete 3D geometry with the green, yellow, red, or dark green, light green, orange portions to identify the holder, non-cutting, and cutting, as somebody was questioning earlier. And that way NC-Simul knows what's allowed to remove material and what's considered a collision object once the simulation starts. So we brought those in, we'll do a full 3-step process inside NC-Simul. And then once we've done that, we'll apply an optimization with both Optitool and Optipower simultaneously, and I'll go through those in a bit more detail as well. As an overview right away, NC-SIML is providing various benefits to truly verifying the G-code before running a first piece at the real machine. The first of which being eliminating long shop floor prove-outs. So in doing that, you're using your time for verification at your PC in your office, not at the real machine, meaning that you're keeping the real machine for production purposes only and not tying it up for any prove-outs. You are reducing new machine setup time. So you're knowing coming right from the programming that the setup that you're placing on the machine is going to work. You're not going to have to take it back off or adjust it for any reason. And the strategy that you've programmed with that setup is not going to cause any collisions or over travels on the machine. You can gain confidence for lights out machining. So feel good about sending a part out there to run overnight without supervision instead of wasting a whole day during programming hours to wait for a first piece to not crash. You can avoid costly crashes and downtime. So of course you want to avoid collisions at all costs and ensure good G-code programs before production. That kind of goes hand in hand. Having G-codes ready for production right away instead of going back and forth between machine to programming to machining again, and so on. So optimization is utilized to address a variety of issues, two of which here being that cutting tools are underutilized. So if your cutting tools are underutilized and your cam system does not adjust for cutting conditions. So if your programming strategies in the first place don't adjust for cutting conditions in material, like varying material engagement in corners or something like that, we can take care of that. And then if cutting tools are underutilized, you could be engaging more everywhere, for example. And there's other examples like feeding starting too far away from the part, or areas where rough material has already been taken out and the rest stock hasn't been calculated like NC-SIML can. All those sorts of things end up reducing part cycle time, increasing cutting tooling life, and using the machines to their full potential. So what are Optitool and Optipower? They analyze CNC programs in an initial cut condition to find out things, physics-based parameters, such as chip thickness, chip flow, feed per tooth, cutting depth, cutting thickness, and cutting speed are those acronyms there. And then there's two sorts of modes that are associated with it, air cutting and learning, and then we'll see the power as well. So air cutting just basically means anytime NC-SIML detects that the tool is outside of material, you can increase that feed rate to a G0 or an Fmax to significantly reduce the cycle time when it's not engaging anyway. And then learning mode calculates how much volume the tool is going through at any given point. And obviously, if you're going through less material, you can increase the feed rate. And if you're going through more material, that means a slower feed rate. And Optipower will do the same thing as far as analyzing the programs off the bat. It can use info from materials and cutting tools and standard databases, and it uses the maximum power of the machine to bring all of the tool paths in any location up to that maximum power without exceeding it, and then therefore it eliminates spindle overload risks, tool breakages, and ultimately collisions at that point. So what information is needed for Optipower? On the user side, you have to know obviously what machine you're running it on and the maximum and idling power of the machines. You need to know what stock material you're using. All information for the tooling, which would be very easy to grab from ZOLLER, but you need to know everything, including like number of teeth and helix angles and etc. And then finally, you need to know the original performance data, but that is calculated automatically by NC-SIML with the cut analysis. And then based on that, it can optimize the rest of the tool paths. So we will do one of those live now. I'm going to go back into NC-SIML. And then as you can see here, this is kind of the main home screen that we started the original project from last time. We're just going to do a separate one that is for has some purposeful errors and things that we can go through. So as the main home screen, you can obviously create a new project from here or open one as I'm doing that's been pre-made. And clicking on it once just gives you a nice little preview of what's about to go on, what machine I'm using, what program I'm running, and so on and so on. So NC-SIML is based on a 3-step process, and it's already doing the first step as I open the software. So the first step is syntax error check. Anything that would alarm out the real machine, NC-SIML is going to identify up front. So those include overtravels and undefined codes. And it also creates the toolpath wireframes around the part, so you can see exactly where you are in space and make sure that everything's going to fit inside the envelope. Step 2 is the actual simulation process. So that's where all the material removal occurs, and it's checking for any collisions, cutting without coolant, cutting without the spindle on, all those sorts of errors that have to do with motion. And from there, you go to step 3, which is the analysis, and you compare your original part model to what we just cut based on the G-code, and it'll tell you if you're hitting your tolerances, if you're gouging the material in any areas, or if you're leaving material. And I'll go through that 3-step process in just a second, and then after the end of that, we'll do one of the optimizations for the Optipower and Optitool, and you can see how you could expect to do that day to day. But just so you know what you're looking at before we go into all that, I'll kind of walk you quickly around the screen to what you're looking at. Yeah. So the left-hand side is what we call the job tree. And this is set up in the same way that you set up your job on the shop floor. So you have whatever process you're running on whatever machine you're using. And then you have a setup on the table. So this project happens to have 2 different operations where there's a stock flip in the middle. But inside of each of those, you have your fixture models, you have your part models, and you have your rough stock. And then you have your tooling. So this is where we have our own NC-SIML tool library, but we also have the tool magazine, which is the ones that can bring in the tools from ZOLLER. Then we just have the initialization, so it knows where in space we are. And finally, this post-process G-code, which is the exact same code that's being run at the real machine. And that's how every setup will look inside NC-SIML. Now at the bottom, your information window, the first window of which being the one that's displaying all of the errors when we do for syntax. When we do the simulation, they'll populate in the same area as well, but we'll get into that in a little bit. You also have a process status tab. So if you've noticed at any given time that I click throughout the program, NC-SIML is automatically updating this data and automatically moving my machine to what it looks like at that location. So it'll tell you things like the tool number you're on, again, coming from ZOLLER or wherever, if the spindle's on and in what rotation, your compensation if it's active, your active reference, and so on and so on. We also have a info window down here. So this is giving you overalls for the program. So again, you can tell how much time each of those tools is running in rapid and in cutting, and each of these throughout the process, even before running a simulation. So this is all done again in that first step with the syntax errors, and you can see exactly how much time that program's running, and we'll be able to see how much time we can save with the optimization when we run that at the end. And then lastly down here, and again, you'll see it a little bit more with the optimization, is a graphing tab. So this one's just feed rate by minute, but we'll add some more interesting components later. But I can drag this graphs tabs back and forth throughout the program to move the program bidirectionally. I can jump tool to tool. I can jump stop to stop, or if there was an interesting piece of the graph, I can click directly on it and see what was causing that. The right-hand side is just the program window. So that same program you're seeing with the Haas demo main, plus any subroutines or macros that are unique to the particular machine you're running it on. So when we build a virtual machine, we'll pull the real macros off your real machine and implement them into anything that you're doing. So this is a simple one, but in the case that this tool change occurs, you can see exactly the motion that's happening inside of that. And if you ever change the way that behaves on your shop floor, we can just update it easily with that text file. And then lastly is just the main 3D window. You have the main machine view, where you see all the components moving around. You have a table view where it locks it in the Z direction and just has the tool moving around the part. And then your motions here, your red wireframes are your rapid motions and your blue wireframes are your feeding motions. And in the same way that you can click on any of the lines of code, you can click on any of the toolpath wireframes, and it's going to automatically bring your tool to that location and to how much material has been machined up to that point. So that's just kind of the basic idea of what you're looking at here. And now I can kind of head back and start what you could be considered to have to do with the day-to-day process once you bring it in from your CAM or elsewhere. The first thing you want to do is that step one, take care of anything that will alarm out the real machine. And to do that, you just click right on the error message. So it's going to show you where in the code it found a problem and what the machine looked like at that location. And this is a simple one, but more likely or not, you'd see this in X and Y, but basically the Z range is, or the Z is out of range by about 1 inch. It's exceeding the machine limits. So whatever you programmed in your CAM, when it loaded at this position on this machine, it can't reach it. So to fix this, it's very simple. You just edit or start the quick editing tool, and I can go in and just change that by 1 inch to come back within the envelope. It's going to ask, do I want to take into account changes? I will say yes. It'll rerun the syntax error check for the new value, and then you can see that this window is blank, meaning that we're good for step one, and everything that would alarm out the machine is taken care of. From here, you move to step two, which is the simulation. And in this, you're basically using three main buttons. You have your reset button, you have your play button, and then this is your speed of simulation slider. So I'll start the simulation in the full machine view so you can see everything moving around. You can see the spindle going to get the tool from the tool change position and coming back in to approach the part to start machining. I can switch from this to the table view and shut off those wireframes and speed it up a little as well so you can see exactly all the material removal occurring. And at any time I can pause the simulation, click on a surface. It's going to show me exactly where it was machining up to that point, which tool was doing it, and how much material had been removed. The other thing you're able to do, if I reset and change to what I call break option, I can put the speed to end result so I don't have to view any of that and have NCSimul automatically stop at my first collision whenever that occurs. So that way, if you've already viewed the simulation or if you're not interested in seeing it and just want to walk away, you can just have it automatically stop for you. So here is the first collision that we've reached. If I click on it, it's going to show me where it was hitting with a little red circle, and it's saying collision between tool holder 7 and rough stock. So obviously on this tool, we don't have enough stick out to be able to machine that pocket. The other thing I have turned on is reverse simulation, which allows me to actually rebuild any material that you want to see during the process. And you can go kind of go bi-directionally with that through the G code with the up and down arrows at any line. So to fix this issue, I can head right into my tool library. And then again, it's your option. If you want to fix it directly from here, you're able to. If you want to fix it from ZOLLER and just re-update the library, that's fine as well. But I can just add a value to this, save and OK, and replace it on the spindle. And then we should see that we're going to have a lot more stick out to that tool. Probably overkill at this point, but then we'll be able to machine that pocket. So I'm just going to reset and turn that break to continuous and let it play all the way through. And then you can see that we have this whole 13-ish minute program being able to simulate within 13 seconds or so. So there's the part flip. It did the first side, flipped over, and now it's going to do the second side. But again, you're not seeing anything because I have it on end result. So there is our final piece. And you'll notice we have a couple scrap items on it. If I had put in some interactive commands, and we also have some functions to do this, you could have it automatically delete any of these anytime it detects two surfaces. Or if you want to do it manually, I can go in and just delete the scraps from the environment so it's not part of the comparison or the collision objects. So that's our final piece. We don't have any more errors down here, meaning that new tool size was good for collisions. So now we're good for step 1 and step 2, both syntax and simulation. And all that's left is to make sure that we cut a good piece. To do this, you have a variety of measurement tools. So you can take these measurements off the part, off the stock, off the fixturing. Anything really works. But I could do, for instance, like a point to plane if I wanted to know maybe the distance between that final surface and what I had for a stock to see how much I was going down in there. Any of these functions will work on any of the pieces. What I touched on earlier was the comparison tool. So this is the one that's comparing the original stock model to what we just cut. So that's the first operation. We want to be comparing the final piece, and that's what we have here. So green is inside your specified tolerance. Red are areas that you've gouged, so maybe that chamfer wasn't modeled. And then blue is excess material, like you saw before I flipped it over to the second operation, because that wasn't part of the final piece. And then lastly, we have cutting planes. So if you have any internal features that you want to take a look at before cutting apart a first piece, you can add a cutting plane and drag it to anywhere on the surface that you like. So maybe you wanted to take a look at those two holes. You could click on the surface to have the tool automatically line up to that location to see what was machining that point when that occurred. Or I can go back to the end of the program here and then do any of them simultaneously. So if I want to do a comparison of that second part while I was inside of the material here and take a measurement off how much that hole was drilled large or maybe ultimately threaded, I can do that as well. So that's kind of your basic process that we do to get a job from the CAM system, import the ZOLLER tools, verify it for syntax, verify it for collisions, and then make sure that you're cutting a good piece. And then you can send this new edited file, because we changed that one value with the save program, directly to the shop floor and know that you could run that lights out first time. However, beyond that, we're going to go into one of those optimizations like I was saying. So prerequisite, just make sure that you have simulated once and you don't have any errors, so you're not trying to optimize with an error-ridden code. But then all you have to do is hit this optimization button up here, and it's going to start the module. First thing you want to do is add some settings. In the cut analysis, so this is identifying the initial conditions of the programming, so it knows not to exceed any of these, provided that that first piece was a good piece. So the first thing you want to add is a segmentation value, basically how often it's going to recalculate conditions. You want to say which tapes, or which programs I should say, are to be optimized. So you can choose to do only finishing passes. You can choose to do everything. Obviously, we don't want to do the tool change macro in this situation. And same with here. So once you've chosen the tapes, you can specify different sequences, even if the tool is used for both roughing and finishing. And that's all to do with the normal optimization. And then the stock material comes into play when you start to talk about Optipower. So this is where we're identifying the material types for the tools. So I'm just going to choose a hard metal, and then you want to choose your machine empty power. Most machines are between 1 and 1.5 kilowatts anyway. So we can put that in as our power. And now I'm going to hit compute, and this is the bulk of the computation. So it's doing all the cut analysis, and then we can choose between 3 different optimizations that we're going to do. So the air cutting, again, to recap, is anything that's not touching the tool outside of material. The learning mode is inside a material to create a constant chip thickness or chip flow. And then the Optitool is optimizing based on the power of the machine. So here are our initial cut info. Again, by sequence, you can see the maximum engagement for depth, maximum engagement radially, so radially and axially, how much volumetric it was going through at any given time, and then the maximum power of the machine. So you're kind of looking here to see if anything has already been exceeded and is way out of line. So maybe this 25 seems like a little bit high, so we'll have to keep an eye on tool 7. So with that in place, it's time to set the settings for the actual optimization. And you can do any of these, you can mix and match. You could do air cutting and for just roughing, and then air cutting for just finishing, and then air cutting and in material for roughing, but it's up to you. But for today, I'm just going to put all three, air cutting, adaptive, and power, into the same one. So here's the adaptive one. I just click this button to add an adaptive process, and it's going to show those same operations that were greenlit. You have one last chance to check or uncheck any sequences. Then you can go in and set some security values. So engagement and retract pre-machine distances for engagement and retract. So basically, once it hits these values, it reverts to your original feed rates. And then once it's out of material, you can say if you want to put it in G0 or if you want to put it in an F max for your machine, and if you want to optimize plunges. And then the last thing is strategy. So you could say to do it with all motions, or you can say to do it just without plunging or ramping. And you have two strategies to choose from. One is for soft material, which is the volumetric one, and one is for hard material, which we chose and is for a chip thickness. So we'll do that one. And then when we apply, it's going to apply the maximum engagements for those, as well as the maximum power the machine achieved. And that 25 that we wanted to keep an eye on, we can go in and change that to the 14 like the other one, so we're not exceeding anything, and just hit compute one last time from there. Okay, so now it's done. The first thing you can take a look at right away as far as numbers go is the cut info. So you can get optimization readouts for the entire program right away. So our original time, it calculated as 12 minutes and 24 seconds, and our optimized time brought it down to 9:39. So we saved about 22% or almost 3 minutes just by optimizing the air cuts and in material, as well as the power of the machine. And specifically, you can go through tool by tool. I won't do it, but to see exactly how much time you saved for each one. The other thing you can see right away, if I hit compare, is the original programming visually to what we just optimized. And again, it'll show you at what given point how much time was occurred or how much time was taken up at that point in the program. And then you can see any toolpath that has been rewritten is in yellow in wireframe around the part visually in the 3D window, and is also highlighted in purple in the G code there. And finally, the last thing that you can view visually is the graphings, which I touched on a little bit before. So we can quickly go across and add different variables and see our peaks for anything. So instead of feed rate, I'm going to go in and turn on the power of the tool, or the cutting power, I should say. And then based on this, you can quickly look across and see if anything looks out of the ordinary. I can turn just the single tool on. I can view them all at the same time. But you can see how the cutting power has pretty much been standardized across all the tools now, not exceeding, say our machine was 20 max, we've brought everything up to about 15 maximum. So it's really easy to see all of that visually with the graphing tab. And basically at this point, you're done. All you would have to do is hit generate here, and it's going to generate the new G code with the optimized feed rates. And then you can export that one to the real machine. You can decide, it automatically creates another simulation process in NC Simul as well if you want to watch it simulate again with the new feed rates. But yeah, at that point, you've done everything. You brought in the tools, you've verified the part, you've optimized it, and you're ready to send this out for production.
Okay, thanks, Christopher, for this great demo. So we have a couple of questions that came during the demonstration. We address some of them. So the first one is it possible to transfer tool assembly, turning tool assembly between TMS and the simulation? Cedric.
Yep, that is possible. Just the one way though, we're gonna do it from ZOLLER into NC Civil, not the other way around.
Okay. Another question, I think it was answered, but I prefer to ask it in case it went through without getting addressed. Will it be possible to measure the tool load based on cutting conditions, such as power from NC Simul? Christopher?
Yes. Yeah. So if it might have been really quick, but at the very end of that table, it was calculating the cutting power, not only the maximum, but tool sequence by tool sequence. And you can break that down as much as you'd like. But yes, you can see the exact load on the tool.
Another question for NC Simul, can the system detect a plunge to avoid insert failure? And I would assume is when a tool is not capable to cut in the sander.
Yep, we can select any part of the tool as cutting or non-cutting. And if you don't want it to use the center, you just need it to use the edge. We just go in and select the center point as non-cutting.
Okay, so how easy it is to rerun an optimization on a new version of the same program, same process, in the case of a CAM process change? So I'm not sure to understand exactly the question is, but yeah, the question is how easy it is to rerun optimization on a new version of the same program and same process as in the case of a CAM process change.
If it's a new G code, you would just have to do the same process as what I did. You still have to run the initial cut analysis to see what it knows, and then just run the optimization on that. I'm not sure I quite understand either, but hopefully that gets you to the process. Just export the same way. If it's different code, we'll run it differently on the same setup. Maybe the setup's the same and the code's different. We'll just still run the initial cut conditions with the new G code on the same setup and then optimize from there.
Yeah, for sure, to add that, we can export optimization setup that you did for one job and re-import it on a new job. So you could export and re-import easily a setup for optimization. What if we have a full 3D model of our indexable cutters? Can these be imported into the ZOLLER TMS and viewed as an assembler tool? Cedric?
I can answer that in different ways. There's definitely possibilities. It's just some of the process. Usually there is a possibility where we just use Tools United or Machining Cloud, where we have the kind of possibility to bring in 3D graphics. But yeah, I mean, there's different possibilities. Again, it all depends on where it's coming from and what file it is to get that created. But usually the way I do it, I go on the vendor's website. They have drawings and graphics, and I usually get those over into the ZOLLER database, but most likely more in the single component level rather than the full tool assembly.
I have another question that I will take. So is it possible to detect deflection or probable deflection based on tool loading? So it's not possible as an industrialized solution. So in the current status of NC Simul, no, but there is some projects with laboratories that made the things possible. So it will be possible at some point to detect deflection, but for now, as it is in NC Simul, no. Another question for you, Christopher, is it changing the feed rate on different line in the program?
Yes, it's changing feed rates for any of those lines that were highlighted in purple. A feed rate has been changed, but it won't change any trajectories. So whatever you programmed, it's just playing with the feed rates on those lines.
Okay, I have a follow-up question. Would it break a feed move to change the feed rate in the middle of the move?
We can set comments to allow it to do that, yes, but what you saw today, no, it did it for the whole line, but ultimately, if you wanted to get that specific, we are capable of doing it.
Yes, I confirm we have some G2, G3s, for example, circle that we can break to change the feed rate in the middle of the move. So the answer is yes, yeah. Okay, are the machine custom or are the stock machines from the manufacturer? Christopher?
So we take the machine kinematics from the manufacturer so that we know it's exactly what your machine is looking like, but then each machine controller is completely custom because we have to make sure that every setting that's been ticked on your machine is ticked on our virtual machine. Any G or M code that you're using in your shop that's specific to you is being reflected, any macro, et cetera, et cetera. So every machine that's delivered is unique, but the shell of it is going to match exactly what yours is as well, but comes from the manufacturer.
Okay, thank you, Christopher. So this is the end of the question and answer. Thanks for everyone to be with us. As a reminder, it's going to be recorded and available online, I would say early next week. If you have any questions, don't hesitate to contact Cedric or Christopher, and thank you, both of you guys.
Thank you.
Thank you.